Hello, we're back. We're gonna do the second problem. It says a particle of mass m starts at rest and moves a vertical distance of a gravitational field. Force equals negative minus times gravity. Okay. Find the work done by the force going to y1 of 10 meters to y2 of 6 meters. So we're gonna, in this one, we're gonna draw a diagram. I'm gonna draw a diagram which represents the problem. So in this case, they're talking about this point over here, which is going down. But in this example, it's not negative when it's going down. Since it's going down and gravity mg is going down as well, both are going down, that means there's no change. No change means it's positive. So it would be 4. This will be 4, of course, because it equals to 10. And 6 and 4, which gives you 10. Now we're gonna do the second example, part B, which explains, it says find the velocity at v equals v times y equals 6 meters. So we said work was change of kinetic energy. So we're gonna write that down. It's the change of kinetic energy. So in this case, we said it was half mv squared equals 6 minus 1/2 mv squared equals 10. To 10. Now, what we get here is, of course, this is the y and a y and a y. The y10 is the one that we got from the first example, which is y1. y2 will be this, y2, y1. So in this case, it will be v equals the square root of g to g8 or 8g, which equals to 80 square root. 80 square root. It's about, not 80, 81, which equals 9 meters per second. Alright, so see, we're gonna generalize the equation for any change in y. So for any change in y, it will be mg to the change of y to the 1/2 is the same equation all over again. So in this case, we're going to isolate the final velocity. So we're left with 2 g of the change in y. That would be our equation. Yes, so the next one is D. And for D, it says find the potential energy associated to the force, and they give us that formula. So this is a long process, but we're gonna get through this. Okay, so okay, so it will be D. D is so the work equals negative the change of U. We're gonna use U as potential energy, and we said we had two different Y's. We're gonna call the Y's A and B. A and B. In this case, y1 was greater than is greater than y2. So we're gonna prove that. So we're gonna prove that both of them will be our potential energy. So it would be U. It would be y1 and y2. U y1 and G y1, and then U of U2 and G y2. Both of them will give me in this case the formula for the potential energy. It will be mg g1 minus g2. We multiply mg both sides, both terms I mean, and in this case we conclude that even if the work is negative or positive, both y1 and y2 will be affected no matter what, because it all depends on what the problem says with the change in kinetic potential, in this case potential energy. So it will be U y of y, it will be mgy. Yep. Sorry. So the letter E, it says establish the principle of conservation of mechanical energy. Yes. So we're gonna jump to here, E. So the work, it was the principle of conservation of mechanical energy. Okay. So once again, we said work is the change of kinetic energy. Kinetic energy is the Kf minus Ki, Kf final, Ki initial. And that would be either, it depends on the problem, Kfk plus Ki, or this could be represented with the U potential energy. Alright, that will be the end of the